Hello, beautiful babies. All right, so we are on day practice 2 of week 13. All right, let's do this. So Taylor walked 1 and 37 hundredths miles in the morning and 2 and 3/10 miles in the afternoon. How many miles did he walk altogether? So make your bar model. All right, so you don't know how much he walked altogether, but you do know that in the morning it was 1 and 37 hundredths, and you know that in the evening it was 2 and 3/10. Okay, so using our handy dandy problem solving flow chart, okay, do we know the total? No. Do we have equal parts or groups? No, we do not. So that means that we need to add. Our bar model even looks a lot like this. Okay, so here we go. You have to add these two parts together to get the top part. So let's do that. You've got 1 and 37. Ooh, I don't like the way that looks. Sorry, the paper picked up on me. Let me see if I can smooth it down. Let me go underneath here. 1 and 37 hundredths. Then underneath that, you've got 2 and, I tell my kids, line up your ands, line up your decimals, 2 and 3/10. Miss Ross, what do I put in that blank spot? You put a 0 in the blank spot. All right, so here we go. We're ready to add. You got 7, 6, decimal 3. So all total, Taylor walked 3 and 67 hundredths miles. And I like to highlight it. All right, next one. Shelton had 359 books to put on shelves. He can put 27 books on each shelf. So how many shelves does he need? Okay, so you've got 359 total. Write that down. And on this shelf, he can put 27. And on this shelf, he can put 27. And on this one, he can put 27. And on this one, he can put 27. All the way until he eats up 359 books. All right? So if I'm looking at my problem-solving flow chart, here it is once again. Do I know the total? Yes, I do. Do I need equal groups? 27, 27, 27, 27. Yes, I need equal groups, so I need to divide. I am not going to be scared to take out a piece of paper and to divide on a separate sheet of paper because you're going to need the room. So I'm going to zoom in a little bit. I've got 359, and I'm dividing it into shelves of 27 books on each shelf. So I tell my kids all the time, at least give yourself a couple multiples of the divisor. So I've got 27, 2 27s would be 54, 3 27s would be 81, and I'm going to stop there, okay? All right, so how many 27s are in 3? There are none. How many 27s are in 35? There is 1 right here because 2 is too many. 1 times 27 is 27. And when I subtract, I have to borrow, and then this brings down an 8 because 15 minus 7 is 8. Then I'm going to bring down the 9. The new number that I'm dividing into is 89. How many 27s are in 89? Well, we're pretty safe with saying 1, 2, 3. Because if you add 27 to 81, it's going to be way bigger than 89, right? So we know it goes in. Actually, if you add 27 to 81, it gives you 108, and that's way too much, right? So how many 27s are in 89? There are 1, 2, 3. There are 3. 3 times 27 is 81. When you subtract, you get an 8. And so what that means is that you've got 13 shelves that are going to have 27 on it. It'll be 27, 27, 27, 27, 27, 27. You're going to keep going until you fill up 13 shelves. But then there will be 1, 2, 3, 4, 5, 6, 7, 8. There's going to be 8 books left. So this is 8 books left. Now, are we just going to take those 8 books and are we going to throw them in the trash can? Are we going to just shove them under the bed? Or are we going to get another shelf? We're going to get another shelf. So you would have 13 shelves that have 27 on them, and then you're going to add one more shelf for these leftover 8 books, and that gives you 14 shelves in all. And I'm going to highlight that because that is my answer. So you'll have 13 shelves that have 27 on it, and then you'll have one sad little shelf that's only got 8 on it, totaling 14 shelves in all. All right, next one. Michael sold candy bars to raise money for his field trip to Busch Gardens. For 16 days, he sold 52 bars each day. For 8 days, he sold 37 bars each day. So what was the total? All right, so here we go. Draw your bar. You have no idea how many total bars he did, okay? But you know that he did 16 days of 52 each day and 8 days with 32 candy bars each day. So draw yourself 2 bars. I'm going to draw one that's a little bit smaller and one that's a little bit bigger because this one is 16 and 52 each day. So he worked for 16 days times 52 candy bars each day. Then for the last 8 days, so you've got 8 days that he sold 37 candy bars each day. This multiplied and this multiplied. When you get your 2 products, you'll add them together to get your total of candy bars he sold in all. So here we go. Let's do that. Let's do 52 times 16. I always like to put the big number on top. It just makes me feel happy. I'm going to turtle head this thing up. 6 times 2 is 12. Leave the 2, carry the 1. 6 times 5 is 30, plus 1 more is 31. Cross this, kill the babies. Cross, put a collar on it, and drop an egg. Bloop. Then 1 times 2 is 2. 1 times 5 is 5, and you can add them together to get 2, 3, 8. So in the first 16 days, he sold 832. All right, now we're going to do the 37 times 8. I like to put the big number on the top. 37 times 8. 8 times 7 is 56. Leave the 6, carry the 5. 8 times 3 is 24, plus 5 more is 29. So 296 in the last 8 days. But don't forget, the last thing you have to do is you have to add these 2 together to get your grand total. So you've got 832 added to 296, giving you 2 plus 6 is 8, 3 plus 9 is 12, carry the 1, 10 plus 1 more is 11. So your total answer is he sold 1,128 candy bars in all. And there is my answer. All right. Next one, Miss Ross's science class recorded the height of a plant every day for 2 weeks. What type of graph should they use to share their data with the other classes? So this is every day for 2 weeks. How many days is that? That's 14 days, right? So day one, day 2. Let's do this. So if we've got a graph, and we've got day 1, day 2, day 3, day 4, day 5, day 6. All right, so let's just write the day, okay? This is going like this. 1, 2, 3, 4, 5, 6, and the days are going across the bottom, okay? Then we're going to have the height of the plant. So let's say it started at 1 inch. 2, 3, 4, 5, 6. This is the height of the plant, okay? Now, let's talk about what this would look like. So on day 1, maybe it was 1 inch. Maybe day 2, it was still 1 inch. Day 3, it was 1.5 inches. Day 4, it was 3 inches. Maybe somebody put it in the sun. Day 5, it was still 4 inches. Day 6, it was 5 inches. Okay, this is, and we've done enough of these that you should recognize it, it's change over time data. you are looking at how much the plant has grown over time. It's change over time data. So this is a line graph. And we have done so many of these over the last couple of weeks. You guys are probably sick of looking at a line graph, but they do show the change over time. All right. And the last one, which statement is true? All rhombuses are squares, all squares are parallelograms, all parallelograms are rhombuses, or all quadrilaterals are parallelograms. Okay, so I'm going to pull out my handy dandy chart. You know what? Actually, I'm not even going to do that. I'm not going to pull out my handy dandy chart. I'm going to show you how to do a quick and dirty version of it on here. Okay, so first, at the top, you've got the Q. It's the quadrilateral family. Then you've got the brothers. Okay, you've got parallelogram. We call him Graham. And then over here, we've got the other brother. We've got Trapeze. Okay, so in the quadrilateral family, there's two brothers, Graham and Trapeze. Trapeze never has any children, remember? But Graham has twin boys, and he names them Rhombus and Rectangle. And then they can't decide on a dog, so they want their dog to have characteristics of both of them. So they decide on a dog that is 4 equal sides and 4 right angles, which is a square. Okay, so what you have here is you have a quick and dirty version of the quadrilateral family, okay? So the quadrilateral family is this thing. We've been working on it for days and days and days and days and days. I'm sure you guys are so sick of me talking about it. But what I did was I just did a quick dirty version of it here so that you also know how to do that. So remember, quadrilateral family, 2 brothers, the twins belong to Graham, and then the dog is the square belongs to rhombus and rectangle. Here we go. So it is always the things that are above it. And since these are all questions, you can use the always. It's always the things that are above it. All right, so here we go. All rhombuses are squares. Well, that doesn't work because a rhombus is only the things that are above it. A rhombus is always a parallelogram and a quadrilateral. It is not always a square. That's a no. All squares are parallelograms. Well, here is square. Here is gram. A parallelogram is above the square, and that is true because it is always the things that are above it. All squares are parallelograms because what is the rule for a parallelogram? A parallelogram has 2 pairs of parallel sides and its opposite sides are equal, and a square totally has that. It has 2 pairs of parallel sides and its opposite sides are equal. So definitely that works. Let's just check the other 2 to make sure. Next one, all parallelograms are rhombuses. Well, parallelogram is only always a quadrilateral. It's not always a rhombus. And all quadrilaterals are parallelograms. Well, that's not true because sometimes it's parallelograms and sometimes it's trapezoid. It's not always parallelograms, so that's not going to work. So your answer is B. And remember, practice drawing this quick, nasty version of the quadrilateral family hierarchy so that you can, when it comes test time, you can just slap that down on the paper real quick. Quadrilateral family, 2 brothers, Graham has twin boys, and then the square is the dog. All right, love you guys. Bye.